Today we're going to look at the operation of lift stations, but to be more precise, the maintenance of pumps, motors, and compressors, and record keeping of lift station operation. And we can't forget Gonzo, even though Gonzo himself forgets everything, especially the right way to do things.
Yeah, sometimes I have trouble remembering things. I went to the doctor the other day and I told him that I had trouble with short-term memory loss. I told him I had trouble with short-term memory loss. I told him I had trouble with
Here's the address and phone number where you can get the manuals and this series of training videos. You'll also find this information on the cover of this video.
Each individual lift station may have different requirements. These differences result from the design and location of the station.
The maintenance program consists of planning, scheduling the work, and performing the work. Necessary work must be scheduled in advance, and the schedule should include all items that must be performed during a given time period. Maintenance work must be performed in a specific manner. Every task must be done the same way by every operator.
Both scheduling and performing are important jobs, but the development of a schedule is the most difficult.
Preparation of a lift station preventive maintenance program requires consideration of three important factors: recommendations of equipment manufacturers, requirements of the lift station, and knowledge previously gained from experience by the operating agency.
Equipment manufacturers and suppliers have recommended repair and maintenance intervals to the equipment that they supply to the utility company.
Usually this information is contained in a convenient binder or manual, or possibly a computer. Information includes frequency of oil changes and lubrication of bearings, types of lubricants, operating temperature ranges, pressures, flow rates, and disassembly procedures for specific equipment maintenance or parts replacement.
During the first year, we need to adhere to the manufacturer's recommendations to maintain the warranty on the equipment.
The equipment maintenance schedule is developed by listing all of the manufacturer's recommendations in sequence according to time periods, such as daily, D, weekly, W, monthly, M, quarterly, Q, semi-annually, SA, and annually, A, according to when these functions or tasks are to be performed.
A time estimate can also be assigned to assist in identifying staff labor hours needed to perform the preventative maintenance.
Your maintenance program needs to be written and followed to make sure that the equipment is properly maintained.
Many tasks follow the same procedure regardless of the manufacturer of the equipment. You know the station, you notice changing conditions, and you are able to compare conditions and operational characteristics with other lift stations.
That sounds like a good idea. Okay. As a field crew professional, feel free to make suggestions to equipment maintenance procedures.
The major problem with applying knowledge from experience is that occasionally procedures other than those recommended by the manufacturer appear better.
Equipment manufacturers have prepared maintenance manuals for use throughout the world. For your own situation, you might have to modify those procedures.
Perhaps the recommended lubricant will not perform satisfactorily due to high or low temperatures in your area. Another example, dusty conditions or humidity may require equipment protection filters to be changed at twice the recommended frequency.
Once the equipment procedures have been developed, work orders need to be issued to the crew to make sure that the equipment maintenance is done at the correct interval.
There also must be a method of recording when the work is completed by field crews. If maintenance items are overlooked or not performed, they must be rescheduled and completed. This information should be checked off against the scheduled work and filed in the lift station book in the main office.
Whether you use the forms that are supplied in the manual or a computer, we must tie these specific procedures to specific dates.
In the case of the form, the top one is retained in the office, and 2 copies are given to the supervisors of the field crews. The supervisors assign the maintenance jobs required at each lift station to the field crews who do the work.
Each individual task, whether found in the form or the computer program, contains a number. This number is referenced in the maintenance manual. This maintenance manual contains the procedures for this task.
When new stations are placed in service, The equipment maintenance procedures are obtained from the appropriate paragraphs in the existing maintenance and overhaul manuals. If new equipment requires different maintenance items or procedures than those already in the existing manual, new instructions are prepared and inserted in the station book and in the field crew's maintenance and overhaul manuals.
After the tasks are completed, the crew leader signs the form, delivers it to the office where the supervisor reviews it and enters it into the permanent record.
With the form, a matchup of the field copy of the form with the original is required.
Okay, is everything complete?
Yes, I got it all logged, and I'm going to put it in the computer now and sign off the monthly here.
When a computer program is used, data entry of that information is made. Whether paper or computer, the results are the same. Assurance that the work was accomplished.
Now let's turn our attention to equipment maintenance, starting with motors and some of the common causes of failure.
Electric motors are the machines most commonly used to convert electrical energy into mechanical energy.
Although a multitude of electric motors are produced today, the most commonly used pump motor is the AC or alternating current induction motor.
Obviously, induction motors are a critical and integral part of the operating ability, efficiency, and reliability of the lift station.
Over the years, research has been done on the types of motor failures. The reasons for AC induction motor failures are overload, contaminants, single phasing, bearing failures, and old age.
The most common components to fail in motors are stator windings, rotor windings, and bearings.
Studies indicate that a large percentage of motor failures can be prevented.
Overload, single phasing, and contaminants are responsible for 63% of motor failures. The good news is that all of these factors can be controlled by the operator.
Since 70% of the motor failures can be attributed to the stator windings, we can assume that the insulation used to protect these stator windings must be one of the causes.
A variety of conditions can lead to excessive heat buildup that will eventually result in motor failure. 4 classes or levels of insulation systems are available: Class A, Class B, Class F, and Class H.
Each class of insulation is defined by the temperature limitation of the insulation itself.
If the temperature limitation is exceeded, the insulation will deteriorate and ultimately cause a premature motor failure.
The temperature rating consists of 3 components: the air temperature where the motor is operating, called the ambient operating temperature; the temperature rise, that's the maximum inside temperature of the windings during normal operation; and the hot spot allowance.
Hot spots are present in every motor because of inconsistencies in the manufacturing process. So in the winding materials, a 10-degree centigrade or 20-degree Fahrenheit hotspot allowance is included. Insulation failure can occur when deposits of dust, grease, or other foreign material accumulates on the windings and prevent the dissipation of the heat generated in the motor winding during normal operation.
One solution is to keep motors clean.
La la la, la la la, la la, la 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 la, la 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 la.
Heat is also generated each time a motor is started. The current required to start a motor is often 5 to 8 times as much as the current used to run the motor.
Therefore, frequent stops and starts of the motor shorten its life.
With short cycling or excessive starts, the generated heat never has a chance to dissipate.
One solution would be to install a reduced voltage method of starting the motor, or change the operating procedures to reduce the start and stop frequency.
If ambient operating temperature is greater than recommended, it will contribute to overheating the motor.
The solution is to reduce the room temperature in which the electric motor is housed through better ventilation.
All motor enclosures are designed for maximum dissipation of internally generated heat.
Keep those ventilation openings clear and free of obstructions.
Single phasing refers to the condition that occurs when one phase of the power source to the motor is lost. When that happens, an induction motor will continue to rotate, but characteristically with increased noise, vibration, and motor heating.
Determine if a single-phase condition exists. We could contact the utility company, or we could look inside the motor control center to see if a fuse is blown or a circuit breaker is tripped. Then we could correct that problem. Another method of preventing that problem would be a three-phase monitor.
Motor overloading is the operation of the motor in a way that causes it to draw current in excess of what's recommended by the manufacturer and shown on the motor nameplate. The heat generated by continuous operation above its design rating is extremely damaging to the insulation. If the motor is operating in an overloaded condition, you must determine the cause of the overload.
The first step in the solution may be to avoid continuous operation. However, continuous operation may be preferable as opposed to starting and stopping when the motor is undersized. You need to find the source of overloading. Is the head or capacity requirements higher than that designed? If so, increase the horsepower. Always remember, improper changes can have disastrous effects on the motor, so know what you're doing. And if in doubt, consult the manual on equipment protective devices.
The motor and pump shafts must be aligned to within manufacturer specifications for the particular coupling, usually within plus or minus 1/100th of an inch.
100th of an inch. Let's see, that's well, this one only goes to 35, so it'd be like three of these. I didn't know there'd be math.
Whenever two pieces of rotating equipment are used, such as a motor and a pump, there must be some means of transferring this torque from the motor to the pump.
Couplings are designed to do this. To function as intended, the equipment must be properly aligned at the couplings. Misalignment of the pump and the motor or any two pieces of rotating equipment can seriously damage the equipment and shorten the life of both the pump and the motor.
Misalignment can cause excessive bearing loading and shaft bending. This could lead to early bearing failure and also excessive vibration and damage to the shaft.
Remember that the purpose of the coupling is to transmit power, and unless the coupling is of special design, it is not to be used to compensate for misalignment between the motor and the pump.
When aligning a pump to a motor, there is two basic forms of misalignment: parallel and angular.
Parallel misalignment occurs when the center lines of the pump shaft and the motor shaft are offset. The pump and the motor shafts remain parallel to each other but are offset by some amount. The second type of alignment problem is angular misalignment. In this case, the shaft center lines are not parallel, but instead form an angle, which represents the amount of angular misalignment.
In addition to misalignment, we're also concerned with end float, which is an in and out movement of the shaft along the axis of the shaft.
In reality, misalignment usually includes both parallel and angular misalignment. The goal when aligning machines is to reduce the angular and parallel misalignment to a minimum.
Misalignment is one of the primary causes of excessive vibration in pump station, motors, and pumps. This misalignment causes early bearing, mechanical seals, and packing failure.
The correct procedure for lubricating motors is as follows. Stop motor, lock out and tag. Wipe all grease fittings. Remove filler and drain plugs. Regarding filler and drain plugs, here's a caution. Zerk fittings should not be installed in both the filler and the drain holes. Free drain hole of any hard grease using a piece of wire if necessary. Add appropriate amount and type of grease using a low-pressure grease gun. Start the motor and let it run for 30 minutes.
The amount and frequency of greasing is determined by several factors. These include RPM, duty cycle, operating temperature, and other environmental conditions.
Excessive greasing can cause as much damage to motor bearings as undergreasing. Therefore, the manufacturer's recommendations should be followed without exception. The key to effective troubleshooting is the use of practical step-by-step procedures combined with a common-sense approach.
Gather preliminary information. The first step in troubleshooting any motor control problem is to understand the circuit's operation and any other related functions.
Ask questions. What's going on right now? When switches are tripped, do things happen the way they're supposed to? Consider everything. Did anything unusual happen? Are the circuits working properly? Are lights dim or out? Was there flooding?
When a system failure occurs, diagnose the problem and try to identify cause. For example, if a motor overload is tripped, something caused it to trip, such as an overload, single phasing, or something jammed in the pump impeller. Don't just reset the overload when diagnosing the problem.
Is it a mechanical failure or an electrical problem caused by a mechanical failure?
Select simple procedures. To localize the problem, select logical ways that you can do simply and quickly.
Make a visual inspection. Look for loose wires, loose contacts, burn wires, burn coils, water, and strange smells.
Converge on the source of the trouble, mechanical or electrical, motor or motor control, whatever it might be. Electrical problems frequently result from some type of phase imbalance, undervoltage, or high ambient temperature.
Pinpoint the problem exactly, its location, and what you need to repair it.
Find the cause. What caused the problem? Moisture, wear, poor design, voltage, or overloading?
Repair the problem and eliminate it if possible. If the problem is in the switchgear or motor, call electrician.
Pumps are used to move wastewater in collection systems when a gravity system is not feasible or is too costly.
In the collection system, pumps are used in the lift stations to move water from lower elevations to higher elevations. Packing is probably the single biggest problem for the maintenance operator maintaining pumps. More pumps have been damaged due to improper maintenance of packing than for any other reason.
Packing a pump is very important. I like to put some soft items around it before I put it in. Then there's just a problem of getting it through airport security.
If packing is not maintained properly, troubles can arise. Shaft or shaft sleeve damage, waste or wastewater contaminating bearings, flooding of the pump station, rust corrosion and unsightliness of the pump and area, and finally, the suction head should not be allowed to go below the packing.
Packing is used to provide a seal where the shaft passes through the pump case to prevent air from being sucked into the pump case and also to prevent that which is being pumped from leaking out.
There are probably over 500 different types, grades, manufacturers, and styles of packing on the market today.
Packing can be round, square, loose, pointed, or almost any size, shape, or form. It is manufactured from jute, hemp, Teflon, asbestos, rubber, lead, or almost any other materials.
The pump manufacturer should recommend the proper packing based on the type of pump and the manufacturer's recommendation.
Selection of a packing material is also based on what is being pumped. For example, water, wastewater, acid, alkali, scum, sludge, or grit, or other material.
Temperature of the liquid being pumped, the grease or water flushing, and the peripheral or outside speed of the shaft are other factors that influence packing.
Do not pick a cheap grade of packing. It will cost you more in the end when shaft sleeves are damaged or maintenance time is required to repack.
Generally, in wastewater pumps, braided asbestos material is used. It can be graphite impregnated, Teflon coated, or of a similar material.
Many pumps use mechanical seals in place of packing. Mechanical seals perform the same job as packing, that is, to prevent leakage between the pump casing and the shaft.
Like packing, they are located in the stuffing box where the shaft goes through the volute. They shouldn't leak.
That's one of the reasons why mechanical seals are gaining popularity in the wastewater field.
Mechanical seals have two faces which mate, preventing water from passing through them.
One half of the seal is stationary, and the other half revolves with the shaft.
Some of the variables are liquid and solids being pumped, shaft speed, temperature, corrosive resistance, and abrasives.
Initially, mechanical seals are much more expensive to install in a pump. However, this cost is gained back in the form of lower operating costs over a period of time.
The limitations of mechanical seals are the high initial cost and the need for a competent mechanic for installation. In addition, when the seals fail, the pump must be shut down. With some types, the pump must be dismantled to repair the seals.
When a pump is fitted with a mechanical seal, it must never be allowed to run dry, or the seal faces will be burned and ruined.
Mechanical seals are not supposed to have any visible leakage from the gland. Of course, they may have slight leakage, which is vaporized. But if the leak is visible, the seal may require relapping, or it may have to be replaced.
Pump bearings should usually last for years if serviced properly and used in their proper application.
Several types of bearings are used in pumps, such as ball bearings, roller bearings, and sleeve bearings. Each bearing has a special purpose, such as thrust load, radial load, and speed. The type of bearing used in each pump depends on the manufacturer's design and application.
Whenever a bearing failure occurs, the bearing should be examined to determine the cause and, if possible, to eliminate the problem.
Bearing failures are caused by fatigue failure, contamination, brundling, false brundling, thrust failures, misalignment, electric arcing, lubrication failure, and cam failure.
Compressors are commonly used in the operation and maintenance of the wastewater collection system.
Well, when it comes to compressors, this is what works best for me. Simple.
They are used to activate wastewater ejectors, pump control systems or bubblers, valve operators, and water pressure systems. They are also used to operate portable pneumatic tools such as jackhammers, compactors, air drills, sandblasters, tapping machines, and air pumps.
A compressor is a device used to increase the pressure of air or gas. They can be complex or simple.
A compressor usually has a suction pipe with a filter and a discharge pipe, which goes to an air receiver or storage tank. The compressed air or gas is then used from the air receiver.
Due to the complexity of compressors, you will probably not be the one repairing them, although they do need to be maintained. And with proper maintenance, they should provide years of trouble-free service.
Each compressor is different, and the particular manufacturer will list their recommended maintenance schedules and procedures.
Inspect the suction filter regularly. Its frequency of cleaning depends on the amount of use and also the atmosphere around it.
There are several types of filters, such as paper, cloth, wire screen, oil bath, and others.
Never operate the compressor without the suction filter. This could introduce dirt into the rotors, blades, and pistons, causing excessive wear.
Lubrication of equipment is probably one of the most important phases of a maintenance operator's job.
Improper lubrication or the lack of lubrication is the major cause of compressor failure.
Most compressors require oiling of the bearings. They can have crankcase reservoirs, oil cups, grease fittings, a pressure system, or a separate pump. Whatever type, it must be inspected daily.
Inspect the reservoir level or sight glass if so equipped. Also, if your compressor has a drip type system, make sure that the drippers are dripping at the proper rate.
Be sure also that the force feed oilers have the proper pressure and grease fittings are greased at the proper interval.
Compressors use a certain amount of oil in their daily operation. Make sure that you check the reservoir level to keep them full.
Care also must be taken not to overfill the crankcase. On some compressors, it is possible for the oil to get into the compression side and lock up or damage the compressor.
When air or gas is compressed, heat is generated, and the compressor becomes very hot.
This tends to break down oil faster, so most compressor manufacturers have special oils recommended for their particular compressor. Also, due to the heat and contamination, it is necessary to change oil quite frequently.
Compressor oil should be changed every 3 months unless the manufacturer states differently. If it is equipped with a filter, this should also be changed.
Cylinder or casing fins should be cleaned weekly with compressed air or vacuumed off. The fins must be cleaned to ensure proper cooling of the compressor.
To have proper lubrication, you must first set up a lubrication schedule. This could be a simple card system, checkoff sheet, or elaborate computer system.
The first thing to do is make a list of everything that needs lubrication, down to the smallest item, including chains, rollers, and sprockets. After you have listed every item on paper, go through the manufacturer's instruction books to determine the frequency and type of lubrication required. Next, determine the amount of each lubricant required. Determine the location of fill plugs, drain plugs, oil levels, sight glasses, dipsticks, grease fittings, and other important items.
Once you've gathered the information, enter it into your equipment history cards or enter the data into the computer.
So the information in the computer. Okay, no problem. Guys, I'm gonna need a screwdriver and probably a hammer. I can get this stuff in there, right? Yeah, maybe some pliers too. Screwdriver and a hammer, pliers. We got it, no problem.
From this information, you can make up a lubrication chart.
Always record each lubrication job when completed, and have the operator who did the job initial the record card. Always keep your lubrication schedules up to date.
As we conclude this training video, we want to remind you of some precautions and some cleanup concerns you should incorporate into your equipment maintenance routine.
When handling or storing oils and greases, some special precautions must be followed. Most lubricants are combustible and shouldn't be stored where there is an open flame.
Signs that state no smoking should be posted outside the building. Be sure to keep all spills wiped up and make sure that all the lids are tight on their containers.
When storing lubricants, cleanliness is of utmost importance. A grease pail or oil drum which has become contaminated with dirt, water, or other material should be discarded. Try using grease cartridges instead of grease pails because they are easier to keep clean and store. Grease cartridges are easy to load in the grease gun and can be discarded when empty. They cost a little more initially, but the savings in handling and a reduction in the chance of contamination may make them cheaper in the long run.
When lubrication is completed, make sure that all oily rags and other materials are placed in a covered metal can while waiting to be picked up or disposed of.
If it is necessary to transfer oil to different cans, make sure they are labeled properly. Never leave an open oil can laying around to use when the unit needs more oil.
A few hours after your lubrication has been completed, inspect the equipment.
Make sure it is not overheating or making any strange or unusual noise. Examine the oil levels to make sure they are at their proper level.
Remember, proper lubrication is the key to successful equipment maintenance. Gonzo's been doing equipment maintenance at a lift station today. Gonzo, have you finished your lubrication yet?
Well, not quite. Could you get my back?
I'm Bill Greenelch. For the overworked Gonzo and myself, keep up the good work.